This video is going to be me doing the rest of the 2.1 guided notes. Now I know I've gone through this first page here. Let me zoom out. Gone through that first page. We've gone through that second page. Page 3, page 4. I did an example. You did one. Page 5 we're dealing with. I did this example and you did that one. And what I'm going to do is start with example number 4. Example 4, write the standard form of the equation of the parabola whose vertex is 1, 2, and that passes through the point 3, negative 6. So we know the vertex is at 1, 2. We also know the parabola passes through the point 3, negative 6. I want to write this in standard form. Please remember that standard form is y equals a times x minus h squared plus k. And as I've mentioned before, I'm always used to calling this vertex form, but your book is calling it standard form, and I did not make that k any better. Anyway, so for me to write the equation of that parabola in standard form using this information, I need to substitute this information into the equation. I know that this is going to be the negative h. I put negative h in there to remind you that we have to do a sign change when I take that value and plug it into the equation. That will go in place of the k. This 3 will go in place of the x, and that negative 6 will go in place of the y. So let's do the substitution. So I know y is equal to negative 6. A, I'm not given that anywhere in this problem, so let's just leave the a. X is equal to 3. And the negative h, remember the sign change. So this is a positive 1, it goes in as a negative 1. K comes in exactly the way its sign is, at plus 2. And I have that equation. Just work this problem out using your order of operations to solve for a. So the first thing I'm going to do is parentheses, 3 minus 1 is 2. I know that's 2 squared is equal to 4. And continuing to solve this equation, we'll subtract 2 from both sides. I didn't mean to do that, but this gives me a negative 8. Bring down the 4a, that cancels out. Then divide by 4, I get a is equal to negative 2. That is not my answer. That just tells me what a is. I do want standard form. So again, using the standard form of a parabola, I'll substitute in all of these values except for x and y. So I'll substitute in the negative h, the k, and the a. It will now look like this. That should be a 1. That is the standard form of that parabola that passes through that has the vertex of 1, 2 and passes through the point 3, negative 6. All right, let's turn a page. Let's take a look at the next one. And what I want you to do is I want you to do this problem out. Go ahead and pause this video at this point, and you work this one out doing exactly what we did with the previous one. All right, so you've worked this problem out. You recognize that we wanted standard form of the equation of the parabola. The parabola has a vertex of negative 4 and 11, and that parabola passes through the point negative 6, 15. So we know this is my negative h, that's my k, that's my x, and that's my y. So let's go ahead and substitute everything in. 15 is equal to a, which I do not know. X is negative 6. My negative h is going to be positive 4. And my k value is a positive 11. Let's work inside the parentheses first. All right, so in this case, negative 2 squared is 4. That will give me 4a. Subtract the 11 from both sides. and divide by 4. So this time I have a value of a is equal to 1. All right, so again, we're putting this value in and our vertex into our standard form equation. Notice I did not write the 1. Okay, so that is the correct answer for that problem. All right, so let's continue. Finding minimum and maximum values. Let me highlight some important pieces in here. All right, so I used to call this standard form, but your book is calling, I believe your book is calling this general form. Since we can't use standard form for this, the standard form, remember, is the vertex form that I use. Anyway, all right, so I have this function, this quadratic function. The vertex is this. You might recognize that. That's my x value. We'll talk about it in a second. But that's how I find the x value given this form of the equation. This is my y value. So this whole entire thing where it says f of negative b over 2a, that basically tells me that I am taking the negative b over 2a, that value, whatever it might be, substitute it into this function in place of the x, work it out, and whatever number I get this. That's my y value. All right, so I don't need to convert this into vertex form to find the vertex. I can use this formula here. Now, you might recognize this also. That is the formula to find the axis of symmetry. The formula for the axis of symmetry, or the equation for the axis of symmetry, remember that's the vertical line. It cuts right down the middle of the parabola. Since it's a vertical line, it's going to be x equals whatever value of x that vertical line passes through. That's also the x value of my vertex. Now, how do I find the y value? Whatever I get here, put it in there in place of the x, work it out, and whatever answer you get is your y value. If your parabola opens upward, remember a is positive, then it will have a minimum value. If a is negative, then it opens downward and it will have a maximum value. Okay, so if it opens upward, it has a minimum value right there. If it opens downward, it has a maximum value. All right, so let's use that information to answer this next question. Example 5, the path of a baseball is given by the function f of x is equal to negative 0.0032 x squared plus x plus 3. Where f of x is the height of the baseball in feet, and x is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball? Okay, so I see that a is negative. That's my leading coefficient. That's a, that's negative, so that must mean the path of the baseball will look something like this. It starts here, hits the ground there. So the maximum value. So we want to know the maximum height of the baseball. Let's start off by using the formula to find the axis of symmetry. This value right here, I've already mentioned, is a. That value right there, obviously, is just an x, so my b value is equal to 1. This is my c value, but I don't need my c value for this problem. So x is equal to the opposite of b over 2a. b is positive 1. Opposite of that is negative 1. A is equal to negative 0.0032. And if I multiply that denominator, I get negative 0.0064. Let's get my handy dandy calculator out. And let's do -1 divided by -0.0064. And I get that value, 156.25. So x is equal to 156.25. If I was looking for my vertex, there's my x value of the vertex. I'm not looking for my vertex. I'm looking for just the y value, just the maximum height. But obviously I have to find the vertex to answer this question. Now, I'm going to do the second part here. Remember, I mentioned here that whatever value I get here gets substituted into our function in place of the x. So looking at this, I have y equals -0.0032x, which is 156.25 squared, plus 156.25 plus 3. Okay, so again, let's just type all that into the calculator. Okay, assuming I typed everything in correctly, my y value is equal to 81.125. That is the maximum value, or the maximum height in feet. This is my vertex. And what does all this mean? It means that the ball traveled horizontally 156.25 feet, and at that point, the ball is 81.125 feet high, and that is the maximum value. Okay, so that is example 5. All right, so for this problem, find the maximum height of the baseball. The path of the baseball is given by the function f of x equal to -0.007 x squared plus x plus 4. I'm going to have you do it. And at this point, just go ahead and pause the video so you can work it out on your own. Okay, so you've worked this out. You started with x equals the opposite of b over 2a. You saw that the function has a b value of 1. So opposite of b is equal to 1. So opposite of 1 is -1. The function has a value of -0.007. And times 2, that should be -0.014. I hate decimals, so let me just double check that. Yeah, okay. Let's go ahead and divide that out. And I get 71 point, let's round that to 71.43. Okay, so that's my x value. If they asked you to find the axis of symmetry, the axis of symmetry is going to be x equals 71.43. In other words, it's a vertical line that passes through 71.43 on the x-axis. Also, in the context of this problem, the ball traveled horizontally 71.43 feet. Before, or at that point, it has reached its maximum height. So what is the maximum height? Let's take that value and let's substitute it in place of the x. And let's type it all out. I'm just storing that number into the calculator so I can just type in sorry, let me fix that. So since I stored that value in the calculator as x, I can just type in an x instead of typing that number in over and over and over again. The maximum height of the baseball is 39.71 feet. And that is our answer for that problem.